Welcome to another session of the PMDG MD11 training from Angle of Attack. This is the second installment of our precision approaches. We will be flying the ILS runway 16 left approach into Rome. ILS approaches can be defined by category, and on the last section, the hand-flown ILS, we flew a Category 1 approach, which allows for a decision height not lower than 200 feet and visibility minimum 800 meters. Now, Category 3 Bravo permits an approach with no decision height and runway visual range of no less than 75 meters. It is a common misconception that the Cat 3 Charlie or Cat 3C is used for automatic landings, but it is not actually operational yet anywhere in the world. There is no visibility minima for a Cat 3C approach, but the limiting factor is that there is currently no implementation of systems that will allow taxiing in zero visibility. We have already covered the use of the approach and land button on the FCP that arms the localizer and glide slope autopilot modes, but we have not yet discussed the auto land. Now, auto land adds a line, flare, nose lowering, and rollout modes to localizer and glide slope capture and tracking. When descending through 150 feet radar altitude, the FMA roll window enunciates a line. This initiates a side slip runway alignment maneuver to remove any crab angle caused by a crosswind. The rudder removes the crab angle while ailerons are positioned to lower the upward or upwind wing to maintain track along the localizer. At about 50 feet, flare mode activates, which initiates a flare to reduce the sink rate. Thrust levers also retard at this point. When main wheel spin up is sensed, rollout mode engages, which uses rudder to maintain localizer center, which should be aligned with the runway center line. Ground spoilers are deployed automatically, the same as any other approach, partially at touchdown, then fully upon nose wheel touchdown. Auto throttle disengages upon initiation of reverse thrust, and autopilot will need to be disabled before attempting to turn off the runway, obviously. It's pretty astounding what these aircraft are capable of. We will be adding a 10-knot crosswind component simply to demonstrate the capabilities of this system, as I just explained. With that explanation out of the way, let's go through the chart. We will jump in about 30 miles from the Tarquinia VOR on the Giglio 3 Bravo Star, with the FMS flight plan fully set up for the approach. Installation of the star and approach into the flight plan is a task that would normally be accomplished in the cruise. The top of descent is computed with the entire remaining flight plan in mind. In the cases of the VOR and localizer approaches, we were able to leave the programming of the star and approach until well into the descent, as there was minimal disruption to our descent profile by doing so. But in the case of this approach, however, it would not have been practical to program the star and approach so late in the flight, as we would have to descend very quickly to get on the revised vertical profile. So we will therefore be joining the flight with the flight plan finalized, but we will still review it to confirm that all is in order. ILS localizer intercept will occur at Mixo and glide slope intercept shortly thereafter. We will get in landing configuration by the final approach fix, and from there monitor the instrumentation very carefully all the way down to touchdown and rollout. So let's go through the facts to finish up our initial chart briefing. Frequencies. The most important nav frequency is the ILS of 108.10. The only other frequency of major significance to us is the Ostia VOR 114.9er. We will be using this in the event of a missed approach. Altitudes. The first effective hard altitude restriction on the approach is at the final approach fix, 10 DME from the Ostia VOR. Gulpo and Mixo have minimum restrictions of 4,000 and 2,500 respectively. When selecting the approach in the FMS, it sets automatically a minimum 4,000 feet restriction at Gulpo and a 2,500 foot target at Mixo. There is only about 3 miles between these points, and losing 1,500 feet in such a short distance would require a very impractical rate of descent. So we have therefore revised the FMS restriction to a minimum of 2,500 so that the aircraft will fly a gentle descent angle between GoPro and the final approach fix. Charlie Fox 16 left. Course. Final approach course is 161 degrees. Missed approach course is straight ahead to 2000, thence 186 degrees until intercepted the Ostia VOR's 16 degree radial. Terrain. There is some terrain reaching in excess of 2,000 feet to the north of the field, and some to the east exceeding 3,000 feet. Highest MSA is shown to the east at 5,200 feet. We should be well clear of all of this. It is worth noting that the missed approach is over the sea, including the hold at 19 DME at Ostia, so we won't have any terrain to deal with on the missed approach. Safety. The main point here is that the first point at which we will get visual with the runway is when we're but a few seconds from touching down. A near zero visibility approach places a lot of trust on the aircraft's systems to do their thing correctly and on you to monitor them effectively. As always, I'll be yapping away throughout explaining the systems, etc., but this is a situation where a sterile cockpit is particularly important. It is also important to keep in mind the restricted area shown in pink. We will be well clear of these vertically and in cases of Romeo 53 and Romeo 14 laterally as well. So as far as safety, just keep in mind that you've got to be focused on this one. Just because it's on auto land, it doesn't mean it's doing everything for you. You need to have to monitor the systems. We will get started with the airbag checklist now by getting the ATIS. Rome Airport Information Bravo. Main landing runway 16 left. Wind 230 degrees at 10 knots. Visibility 100 meters. Clouds 100 overcast. Temperature 8, dew point 7. QNH 1007. Information Bravo. As I explained earlier, we have pretty much completed the flight plan install. We will check through it now, though, to confirm that everything is as it should be. So let's switch the ND to plan mode so that we can step through the waypoints as we check each one of them off. GoPro is in place with a minimum of 4,000 feet set. MIXO is up next with our revised minimum altitude of 2,500 feet. Charlie Fox 16 left is the final approach fix, target 2,500 feet. Oscar Mike 16 left is the outer marker, 158 knots and 1,350 feet. This fits with the vertical profile on the chart. Runway 16 left is, of course, the runway showing altitude 13, which fits with the threshold elevation of 13 feet shown on the chart, and the missed approach is also set correctly, or so it appears to be. It's always important to look over these specific aspects of the approach. I know we haven't always been diligent in doing this, but in this particular case, especially since we made our own changes, it's very important that we double check and make sure that the altitudes and waypoints are there and correct. Continuing with the airbag checklist, radios is up next, and we are still quite a distance from the airport, so the ILS has not yet auto-tuned. The ILS will auto-tune when within 25 nautical miles of the station. The frequency and course are 108.1 and 161 degrees respectively, so enter these and drop them into 4 left. We also need to consider the Ostia VOR. This will be used in the missed approach, and we need that there just in case we need to do the missed approach. So you will remember from previous approaches that anytime we select a VOR and course on the nav radio page, a magenta dotted line is plotted on the ND to represent that course. In our case, that would clutter the final approach course significantly, so rather than tuning it now, we will use frequency pre-select feature on this page. So enter 114.9er/160 and drop it in to 6 left. If we need to go missed, we can just line select this frequency and drop it in 1 left. This will save valuable time during the high workload maneuver of the missed approach, so we want to be ready for it just in case it happens. One thing we have not yet discussed at all during this training is identification of VORs and ILSs which were tuned. It is important to verify that the aircraft is correctly receiving the signal of the station that you have tuned. There are two different ways of doing this. It is possible, once the nav aid has been tuned, to listen to the Morse code identifier that it broadcasts. To do this, press the ident button on the audio control panel, then pull the corresponding knob to listen to the station. In our case, that would be ILS 1. You would then listen to the Morse code and check it against the dits and dashes on the chart, or the dits and dots as they're also called. Alternatively, the aircraft will actually identify the station for you. At the moment, 108.1 is shown in magenta below the speed tape on the PFD. Once we get within 25 nautical miles of the field, the aircraft will start listening to the Morse code broadcast by the ILS and decode it. It will then display the identifier here. The identifier per the chart should be Fox Lima Lima. We will verify this later once it has been positively identified. The latter method works just the same for the VORs and NDBs, and legally it is just as acceptable as the first, given that the identification comes from the station itself and not from the aircraft's navigation database. We'll check up on that later on in the actual approach. Up next, as always, is the approach brief. Although we brief the approach fairly comprehensively at the start of each video, I always feel it is important that we wrap it up with a full brief encompassing everything. So here we go. Rome Airport, Category 3B ILS, runway 16 left approach. Chart is valid 2nd June 2010. ILS frequency is 108.1. Austria VOR is 114.9er. Approach is via the Tango Alpha Quebec transition, a roughly 45-degree intercept onto the ILS for runway 16 left. Final approach course is 161 degrees. We have two altitude restrictions before the final approach fix. Minimum 4,000 at Gulpo and minimum 2,500 feet at Mixo. Final approach fix is 2,500 feet at 10 DME at Austria. There is no decision height. Threshold is 13 feet. Transition altitude 6,000. Highest minimum safe altitude is 5,200 feet to the east. Missed approach is straight out climb to 2,000 feet, then a right turn on 186 degrees to intercept the 160 degree radial of the Austria VOR to fly out to a hold at 19 DME. ATIS reported visibility at less than a fourth a mile, and that completes the briefing. Approach descent checklist is up next, so as always we need to complete that as we come on down here. Landing data comes first, and we need to verify that the landing data is checked and correct. And looking at it, looks like we're good to go there. Windshield anti-ice is set to on. We switched on engine, wing, and tail anti-ice before top of descent, given the temperature and dew point spread, which is less than 3 degrees. Decision height. There is no decision height for this approach, so set the DH to 0. Passenger signs, again going back to the overhead, should be on. Hydraulic panel is on auto. Lights, we need to set the landing light, nose gear, and runway turnoff and logo lights on, so quite a few of them. Also verify that the high intensity light switch does not have a lit off indication. Altimeter set to QNH 1007. There we go. And that is in preparation for the transition altitude of 6,000 feet, and that completes the descent approach checklist. As we have always done to finish up airbag, just run through that missed approach procedure in your head one last time. Now, even though we have no decision height on this approach, there is no excuse to take the missed approach any less seriously than you might otherwise. Aircraft equipment failures happen, ground equipment failures happen. There are so many things that could inhibit our auto land from functioning safely. So zero visibility 100 feet above the ground is not a place to be umming and ahhing about going around. Hit toga or takeoff go around at the slightest excuse. So that finishes the airbag checklist. Getting back to the approach now, we are well past the Tarquina VOR and are only a few minutes from Galpo. The vertical deviation indicator on the ND is centered perfectly, so we were right on our vertical profile. In all of the previous approaches we have flown, we have set speeds manually in the latter stages of the approach. There is actually no need, conditions permitting, for the crew to manually set speed at any point in the flight. It can all be set automatically by the FMS, but that is in a perfect world. We will leave the speed control up to the aircraft for this one, as it will show you how awesome it is. The first deceleration command by the FMS will be from our current speed, 245 knots, to 20 knots above clean minimum speed. The FMS commanded speed will drop automatically to this value and will be shown by the magenta dot on the speed tape. The next speed deceleration, as you can see here, will be to slat extend minimum plus 20, then flaps 28 minimum plus 5 once flaps 28 have been selected. Finally, the approach of 158 knots will be commanded upon selecting flaps 35. We will aim to be in landing configuration before reaching the final approach fix of Charlie Fox 16 left. Now, while I was explaining all that, the aircraft successfully identified the ILS signal and has placed the identifier Fox Lima Lima on the PFD. I much prefer this method of identifying stations, as it is just as reliable as listening to the station Morse code manually and presents the information in the simplest of forms right on the PFD. Both the localizer and glide slope deviations are showing correctly now. The aircraft will start slowing soon, so watch that magenta dot on the PFD speed tape. And there it goes. We are below max slat and flap 15 extension speeds, so flaps 15. The drag from the flaps and slats will slow us down quickly toward max flap 28 extension speed. We are not far from localizer intercept, so let's arm the localizer and glide slope tracking by pressing the approach and land on the FCP. Note land armed annunciation on the FMA, and once the localizer is picked up, localizer mode will activate and the aircraft will turn to intercept it. Don't forget that we want to ideally be configured for the landing by the final approach fix. I like to have the before landing checklist completed by this point as well, particularly when performing an auto land. It is very important that this last section of the approach is focused entirely on the safe function of the aircraft. So we have passed through max flaps 28 extension speed, so let's set flaps 28.
Localizer's alive.
And there's localizer intercept as well. And there's glide slope intercept. Localizer and glide slope are now active roll and pitch modes. We want to throw out some drag to expedite our deceleration, so drop the gear and wait for 4 greens. Getting flaps 35 before the gear is down and locked will result in an RL landing gear alert. We are
Flaps
below
35.
max flaps 35 extension speed, so set flaps 35. Speed is now set at V approach 158 knots. We are stabilized on final, so let's go through the before landing checklist. The gear down and 4 greens, spoilers are armed. Auto brakes, we will set those to medium. Flaps, we've just set those to 35. On the EAD, there are no alerts. Before landing checklist complete. The radar altimeter comes in at 2,500 feet. We are also approaching 2,500 feet barometric altitude, which is currently set in the FCP altitude window. When glide slope tracking is active, the SCP altitude is ignored, so the aircraft will continue to descend through it. Understandably, an automatic landing is a very precise maneuver. Systems redundancy is a requirement in all airliners, but in no other situation is it as vital as in the case of an auto land. With the aircraft in control so low to the deck, the need for backup is huge. So passing through 1,500 feet radar altitude, the autofly system performs a self-check, a pass yielding green dual land indication on the FMA. In dual land mode, several measures are taken to ensure safety, and I will list a few of the main ones. All 4 autopilot channels become operational as opposed to only 1. Selection of any autopilot mode other than go around is inhibited. Actuation of control wheel trim switches will no longer disconnect the autopilot. Electrical buses are split to provide complete electrical isolation between autopilot systems, and many other changes happen, but for obvious reasons there is no time to explain them this late in the approach. So within about 10 seconds of passing through 1500 feet radar altitude, the check should complete and localizer, glide slope, and dual land should be enunciated in green on the FMA. And there it goes now. An auto land may still be possible even if not all of the dual land requirements are met. Single land mode is available if system status permits. If not, then the autopilot will revert to approach only mode, where the autopilot must be disengaged prior to 100 feet and then a manual landing performed. We have just passed over the outer marker just now, and in addition to our clean bill of health in the form of a dual land, we also have the green box on the EAD. This is the only situation in which you'll see green indications on the flight mode annunciator. Green validates integrity of the system. Dual land and a green config box are perfect valid reasons to continue with the approach. So don't forget about the 10 knot crosswind we have. The auto land limitations are headwind components of 25 knots, tailwind components of up to 10 knots, crosswind components up to 15 knots. Obviously, we're well within limits with 10 knots for the crosswind. Looking at the drift angle pointer on the PFD heading display, we have a crab angle of a few degrees. You'll see the aircraft kick out the crab starting at 150 feet, and below 500 feet now, we need to be flicking our eyes between the PFD and currently the very murky picture outside. Still nothing to look at. So watch now as this incredible system continues to come on down. And there are the first approach lights right where they should be. 150 feet. Roll mode goes to align, as we'll see here in a second. And there it goes. 50 feet. Pitch mode, flare, and thrust goes to retard. And that'll happen now. Touchdown is when rollout mode happens. And there's retard rollout mode. Spoilers deployed. Auto throttle disengages upon reverse thrust. The aircraft tracks localizer center throughout the rollout, and you'll need to keep an eye on the speed and take out that reverse thrust. At 80 knots, you'll go to idle, and at 60 knots, you will stow the reversers. When you're ready, you can take over the braking manually and disengage the autopilot when you are comfortable. That was the easy part, and now you need to find your way off the runway and to the parking area. So good luck with that. I hope you enjoyed this very, very precise precision approach and the amazing capabilities of the MD11 and its auto land system. So that is it for this session of the PMDG MD11 training from Angle of Attack. We will see you guys next time for the go around episode. Until then, throttle on.